Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me, and before we get into today's topic, please remember to like this video, subscribe to the channel, leave a comment down below, and share a link to this video or playlist with your friends, family, and professional contacts to help me grow this channel as an independent creator. Now, what are we going to be talking about in today's video? Well, we're back on the storage topic around LXD. I did an earlier video that introduced the concept of storage pools. We talked about storage volumes a little bit in that video, but what we're going to be talking about in this video is another feature in LXD that allows you to create what's known as S3 storage buckets. Now, S3 is a protocol that was developed by Amazon originally, back somewhere around the 2006 timeframe. Amazon S3 is short for Simple Storage Service. That's where the name S3 comes from. And since it was released as a cloud storage protocol, S3 has been adopted by many other software packages and cloud vendors out there. Other cloud vendors like Backblaze or Firebase or others out there actually have implemented the Amazon S3 protocol into their storage services so that if you build an application that uses Amazon's S3 service and you want to port that application to a different service, like a different cloud vendor, then with very minimal changes, your application's storage mechanism is going to continue to operate just against different API endpoints rather than Amazon S3's API endpoints. In fact, there is an open source project out there called Minio. This is a really cool piece of open source software that allows you to actually create your own S3 server that you run internally. It's a self-hosted type of software solution. I actually run an instance of Minio myself on one of my servers. And so this is a way for you to just run S3 as a generic service internally. But LXD or LXD actually supports S3 buckets as kind of an internal service to share data between different virtual machine and container infrastructure within your LXD host or cluster of systems. So what we're going to talk about is basically how to create a bucket, how the architecture of buckets with storage pools looks like, and then we're actually going to generate some credentials so that we can connect to that Amazon S3 compatible bucket. Again, it's not an S3 bucket, it's just a compatibility layer for storage. And then we'll actually take a look at some utilities that work with S3 so that we can actually manage the data on those buckets. So for starters, just be aware in the documentation, we're under the LXD storage about storage section here, and this just briefly introduces the concept of buckets. And so if you just do a Control F in your browser, just kind of to highlight the keyword bucket so that you know what we are talking about here in the docs, you can see that it uses the Amazon S3 protocol. Anytime we talk about storage buckets, we most of the time in the industry are talking about Amazon S3 compatibility. And then just similar to storage volumes here, buckets actually get created in a storage pool. So storage pools, again, are where things like virtual disks are created for virtual machines. If you create additional data disks, those also get assigned to a particular storage pool. And remember that LXD hosts can actually have multiple storage pools configured using different supported drivers. So let's go down a little bit further here. I think it's all the way at the end of this about documentation here where it talks a little bit more about storage buckets. So it works with the directory, Btrfs, LVM, and ZFS storage pool drivers. So you do have a lot of flexibility there. And you can also host buckets on Ceph storage. So if you set up a remote Ceph cluster, you can actually use Ceph's object storage instead of RBD, which is remote block devices. And Ceph also has a file system protocol as well. But the third thing that Ceph offers is actually this object storage protocol. So you can also host buckets for LXD on Ceph remote storage if that's what you are using. Now, how do you authenticate to these buckets? Well, very similar to how Amazon S3 authentication works with identity and access management or the IAM service, you actually use what's known as an access key ID and a secret access key. So those are the two different pieces of data that you need to provide to the service in order to authenticate to the service using various software tooling. And there's a lot of different software tools that are compatible with Amazon S3. So the fact that LXD supports the S3 protocol for just doing file transfers between virtual infrastructure is actually a really, really nice feature. Now, one other thing that is pointed out right down here in the documentation is that if you want to use or enable the buckets feature, then you have to make sure that you configure on the LXD host this option right here in the daemon configuration called core.storage buckets address. And then this is really similar to in the video where we talked about setting up remotes. We have to make sure that the LXD engine has a network port listener on it. So basically, we're just kind of doing the same thing where we specify an IP address and port that we want to configure the bucket service to listen on. And then there's a separate document down here that talks about working with buckets. So this shows you how to set this configuration option on the command line. You can also do LXC config edit and fire up a text editor to do an interactive editing of the LXD configuration file. But then once you've actually created the listener, you can then start to create buckets with different names, and you can select which storage pool you want to place each bucket in. For example, you might want to create one bucket that is based on a ZFS-based storage pool, whereas you may want to create a different bucket that is stored on a completely different pool that maybe uses the directory driver or maybe the LVM driver for storage pools instead of ZFS. So this gives you the flexibility to choose which storage pool the bucket is created on and a custom name for the bucket as well. Now, once we've got a bucket created, we can actually go ahead and start writing and reading data to and from that bucket using various tools. For example, you could use the AWS CLI tool. There's a really great open source utility out there called Rclone over at rclone.org. This is a really nice piece of software that you can use in order to manage lots of different storage backends. You can actually see they do support Amazon S3, but it also works with Amazon Drive, Backblaze B2, which also has an S3 compatibility layer, coincidentally. It works with Dropbox, it works with FTP servers, it works with WebDAV servers over HTTP. It works with Microsoft Azure Blob Storage, which is a cloud storage service that's similar to S3, but doesn't actually implement S3 protocols. So as you can see, Rclone supports lots of different storage backends. That's one of the reasons that I really like it. And it's just a nice command line tool in order to manage data generically. So I really like using Rclone, but you can use AWS CLI. You could use graphical tools as well. So if you're running a Linux desktop on your LXD server, you could use a tool like CyberDuck, for example, which is a graphical tool that you can use to manage S3 storage. I believe there's actually another one out there called FileLight. I think this works with S3 as well. Let me just look up really quick. I guess maybe I got the name wrong right here, but there is another open source utility that's based on, I think, the Electron framework that's cross-platform that you can use to manage S3 storage. Of course, Minio has tools that allow you to work with S3 storage as well. So it's just a very ubiquitous protocol, and lots of different software tools and just applications that you can deploy on your self-hosted infrastructure are going to work with this as a storage backend without actually having to create any cloud accounts. Now, we can also generate keys down here. Now, when it comes to access control, when you're dealing with buckets on storage pools in LXD, we have the ability to create either admin permissions or read-only permissions. So there's no granular permissions. You can't say, all right, this key is going to get access to a certain subdirectory within a bucket. Technically, there's no subdirectories, but there's key prefixes in S3. It doesn't get very granular like that because we only have admin and read-only, but those are the two built-in roles as of right now, and for most people's purposes, that should work okay. So we can actually create additional keys. So we could create separate keys for separate applications so that we're not sharing keys across the same application to the same storage bucket. So let's actually see how this works in practice. So the very first thing that we need to do is get on a LXD bare metal server And then we need to make sure that we create the network listener here for the service, and then we can go ahead and start creating buckets on our storage pool. So I'm going to fire up a new shell here and bring it over to this screen. And let me bump up the font size here a little bit. Now, I've already got a bare metal host over here called Pangea. So I'm just going to SSH into my Pangea host. And now I've already got LXD installed. And of course, I've got a separate video that introduces LXD that shows you how to install it. But for now, we're just going to use the LXC CLI to check the version. So I'm currently running what I believe is the latest version. Let me just do snap info here and confirm. Yep, that's the latest version of LXD. And then if we take a look at our configuration of the LXD daemon or engine, let's do LXC config edit right here. You can see that I don't have any configuration options here. So I haven't configured this as a remote server. It's only using the local Unix socket for security reasons. And I also don't have the bucket listener set up either. So in the config section here in our text editor, we'll just go ahead and specify the core.storage buckets address. I'll just copy that so I don't have to manually type it out and probably mistype something. And then we also need to specify where the listener is going to listen on, so which network port, and you can also specify an IP address as well. So let me just open up another shell here and cd into the same server right here. So let me get back on Pangea, and I'm going to look for the IP address of the bridge interface on this host. So I'm going to be looking for the LXD BR0 interface, and then as you probably know from our networking discussion, when you initialize LXD, it creates this separate isolated bridge network on the standalone host, and then when you create virtual machines, again, by default, they're deployed into that virtual bridge network. So what I'm going to do is take the IP address of the host operating system on that bridge network, and I'm going to use that as the listener so that the virtual machines and containers that we create on LXD can access that IP address. So I'll do port 8555 here just because that's the default that they show in the documentation. And as soon as we save this configuration file, LXD will automatically pick up on the changes and it'll create that network listener. So how do we confirm that it's actually listening? So is there anything that we can do to actually confirm that our configuration change took effect? Well, if you install a package on Ubuntu Linux called the nettools package, if we do sudo apt-get install on net-tools-yes, you can see I've already got this package installed. But if you install that, you get access to a tool called netstat. And netstat allows us to take a look at the ports that are listening. And we can also do -- numeric ports so that it doesn't resolve well-known ports to their names. And if we scroll up right here, we should see a list of ports that are listening on the system. And we're looking for 8555, which is right here. So it is listening on Pangea at that port number. So we do know that it's working. Now, again, our host Pangea has multiple IP addresses. So there's another option that we can use. If we do netstat help, we can say numeric hosts as well. And that will prevent the host name from appearing. Let's do numeric hosts, and that way we can see the exact IP address on this host that is listening because we set it up for one specific IP address, not all IP addresses on our network interfaces. All right, so now that we know it's listening on our bridge network, let's go ahead and fire up a virtual machine on that bridge network and make sure that we can access the S3 service from that virtual machine. So let me just do a list here really quick. And I'm just going to delete U01 here really quick. So we're just starting with a fresh environment. So now I should have no virtual machines on here. And we are going to go ahead and launch a new one. So we'll say LXC launch --VM. And then we'll just use the Ubuntu Lunar image. That's just the latest version of Lunar Lobster, which is the 23.04 release of Ubuntu. And as soon as we create that new virtual machine, we'll go ahead and just get an interactive shell in it. And then we can install some tooling and see if we can access the S3 bucket. Of course, we just created the listener, so we also need to create a bucket itself. And to do that, if we do an LXC storage, we can go into the storage context, and then under the storage context, there is another child context called the bucket context. And then under bucket, we can create a brand new bucket. Also, if we go under the key context here, we can manage the keys that are associated with buckets. So once a bucket has been created, we can add additional authentication keys and hand those out to different applications running on our virtual infrastructure. So for now, let's just use the create command, and we just need to specify the storage pool and a name for the bucket here as well. So let's do LXC storage bucket create. Actually, we'll just do LXC storage list. As you can see, I've only got my default storage pool here. So when we do a bucket create, we'll just specify the default storage pool, and I'll call this Trevor Sullivan as the bucket name. All right, so now we've created a bucket on our default ZFS storage pool. Again, it does work with other drivers as well, just we happen to be using ZFS as the default. And now we have our access key ID, also known as the access key for short, and our secret access key, which is known as the secret key for short. And these are the credentials that we'll use to authenticate to the service. So make sure you copy both of those to your clipboard. I'm using the Windows 11 clipboard here, so I can actually have multiple items on my clipboard, which is kind of nice. So I can copy both of those values and then use them in our virtual machine. So let's do an LXC exec u01-bash. That'll get us an interactive shell on our virtual machine. And if we do an IP adder grep 10 dot here, we should see a 10.33 address that is on the same network as the host interface on that bridge virtual software defined network. So we should be able to ping 10.33.204.1, which is the host's interface from our virtual machine. As you can see, that's working perfectly fine. But now we need to attempt to connect to the S3 service. And I'm going to install Rclone to do that, just because it's a really awesome tool for that purpose. So if we go over to the docs and installation here, we can just grab this little install script here. That'll just download the latest version. If you are using an old version of Rclone, you can potentially run into protocol version errors. I know I tried to use, I think it was 1.36 version of Rclone, and I ran into an issue trying to connect to the S3 service. So make sure you're using a newer version like 1.63 instead of 1.36. So what we're going to do now is actually configure Rclone itself. So Rclone is installed and running on our virtual machine, but we need to set up the custom endpoint because we're not connecting to Amazon S3, and we also have to set up our authentication credentials for this utility. So how do we do that? Well, one of the cool things about Rclone here is that we can specify these special configuration variables called Rclone config, and then we can specify what's known as a remote name. So very similar to how LXC uses a remote name to communicate with remote LXD engines, we can actually set up different remote storage engines that have a unique name to them in Rclone. And then we can specify in environment variables the settings for that particular storage provider. Now, Rclone is really huge, and I don't want to get too deep into the weeds on all the details about how Rclone works. I'll kind of leave that to you separately. But when it comes to configuring the S3 provider here, we need to tell it if it's an other compatible provider or if it's going to be officially AWS or DigitalOcean or some other S3 compatible service. So we need to make sure we set the type. We also need to make sure we specify the credentials. We also need to specify the custom endpoint because we're connecting to a specific IP address and port. And then there's actually another parameter that we need to specify on Rclone that bypasses the certificate check, because a self-signed certificate is actually bound to the S3 bucket service in LXD. And because that's not a trusted certificate that's been signed by a root CA, then we have to basically specify that we are okay with using an untrusted certificate. So we'll take a look at how to do that in just a moment. But let's check out the different variables that we need to set in order to authenticate. So let's search for endpoint here. And so what we're going to be doing is saying rclone_config. Let's do export rclone config, and then the remote name. So Trevor data. and then we'll specify, I think it's just endpoint here, and we'll set it to our IP address of our host, :8555. And let me actually prefix that with HTTPS here as well, just to indicate that we are using a TLS encrypted endpoint. And then we will go ahead and configure our access keys. So we're going to use the same prefix here, rclone config, and the remote name, which is going to be Trevor Data. But this time we're going to use the access key ID and the secret access key. So we need to find the variable names for those settings as well. So down under the standard options section right here, it's going to show us all the different options for the different providers here. So we need to make sure that we set provider as well. So let's come back here and tack on provider, and we're going to set this equal to other, because it is not S3 itself. It's a other compatible provider. And then we'll go ahead and specify the access key ID. So we'll just copy that suffix for this variable right here. And we'll hit backspace here, paste that in, and then we'll set the value to our access key ID. And then we also need to specify our secret access key. So the secret access key is going to be a suffix of secret_access_key. And then we'll set that value to our key right here. And I think that should be everything that we need to specify here. So now if we want to use rclone to access this remote, we could say rclone, and then there's lots of different commands that we could use, like LSD to list the buckets that are available. So let's try LSD, and then we need to specify the remote that we're trying to connect to, which I think we called Trevor Data. So let's go ahead and just do colon right here. And since it doesn't seem to like this here, I think I also forgot to set the type of remote. So there's another variable that we need to set called the type of remote, and that's going to specify that we want to use the S3 storage driver. So once we specify that variable, we should be able to run this command, but you're going to see that we end up getting a different error here after just a few moments. And that's because there's another parameter we have to specify in order to ignore the self-signed certificate that is untrusted by default. So there is a setting called no check certificate. It's actually a global flag here. So if you check out the global flags documentation somewhere under here, I don't know exactly how to get to it, but we can just do -- no check certificate, and this will bypass any warnings about the SSL or TLS certificate that's being used by the LXD S3 service. So let's go ahead and just copy that, and we'll just put it somewhere before our command right here. And as you can see, we are able to list our bucket. So now, how do we actually list files inside of that bucket? Well, if we look at the rclone command right here, we can use an rclone ls command in order to list objects in the remote path. So the LSD command allows us to see the buckets on the LXD engine, but then the ls command actually looks into a bucket and lists the objects in there, or files. So let's try rclone ls. We'll specify the Trevor Data remote, and then we'll go into the Trevor Sullivan bucket. And as you can see, there is nothing inside of there. So we can upload a file up into that location by using rclone as well. So what we'll do is specify that we want to copy from a source to a destination right here. And that'll allow us to just copy from the local file system up into that bucket. So let's start out by creating a file. I'll just create a file called test.txt, maybe put some text inside of it as well. Say welcome to LXD on Linux. Go ahead and save that file. And now let's say we wanted to get this test.txt file up into that bucket. Well, we can use rclone copy in order to accomplish that. Of course, our source path right here is going to be a local file. So let's just do rclone copy, and then we'll specify test.txt, and then we'll specify our other options like no check certificate, And then we'll specify the destination that we want to copy to, which is Trevor data as the remote, and then we'll copy it into the Trevor Sullivan storage bucket. All right, so now we've copied that file up into the bucket. Let's hit up arrow a few times and find our ls command right here. So it should be somewhere here in my history. Let's just go ahead and use this one and do ls. And now you can see that we've got test.txt inside of that bucket. So the nice thing with the S3 buckets feature in LXD is that we don't have to explicitly mount the bucket into the virtual machine as some kind of storage volume. Rather, it's just listening on the network like any other network service is. And so as long as our virtual machine has network access to that service, and as long as we have authentication credentials to access the S3 service, we are able to access data that's stored inside of these buckets. So we could spin up another virtual machine. We could go through the same process of installing some S3-compatible client utility like Rclone or AWS CLI, and then we could attach to that same bucket and grab data that's been put inside of that bucket, and any other containers or virtual machines on our network would be able to do the same thing. So it's a great way to be able to share data centrally across many different instances within your LXD environment. So that's pretty much mainly what I wanted to show. You can also create restricted credentials. So if you wanted to set up a read-only user, for example, we could do LXD storage bucket and then go into the key context right here. And this will allow us to create a new key. So let's do the create command right here and then specify the role parameter, which is either admin or read only. And if you don't specify that role parameter, the default value is going to be read only as well. So let's go ahead and just create a new key. We also have to specify the storage pool and the bucket that we're creating it for, and then a name for that key. We'll say create default storage pool. And then the bucket is called Trevor Sullivan, and the key name, I'll just say read-only user. And so now we have this new key here. So we'll go ahead and just copy these credentials, and then we'll change the credentials in our virtual machine right here. So let's find the export command where we specify our credentials, and we'll just change the secret key to our new one. And we'll also specify our access key ID here. So we'll just remove the old one, plug in the new one. So now if we try to upload a file or delete a file on the remote, then we should not be able to. So let's try to delete that test.txt object by using the delete command right here. If we do rclone delete, we just specify the remote and path. So let's do rclone no check certificate delete. And then we'll specify Trevor data as the remote config, the bucket named Trevor Sullivan, and then test.txt, which is the object name. And sure enough, we get access denied. You can see it actually retried several times here. And so we don't have permission to modify the data on that bucket, but we should be able to read it. So if we wanted to copy from that remote, we could just do an rclone copy command, and then specify a local file name like test2.txt. And sure enough, we're able to download it to our local file system because we do have read access. Looks like it actually put it under a directory there. But there's our file that we downloaded. And so that's how we can use a read-only key for the LXD S3-Compatible API. Anyway, that's pretty much everything that I wanted to show you how to do with S3 and LXD. So thanks again for joining me on this video. I hope that you learned something new, and I hope that you'll join me for my next video. Please don't forget to like, subscribe, and check out the playlist on LXD for more great videos. Take care.